Hey, welcome back. We are continuing with our inverse functions. We're still in 5.1, and we are going to now find some formulas for some inverse functions. And keep in mind, if the original function is not one-to-one, then its inverse is not going to be a function. And so that's why that was a big deal. Anyway, so on to number 9. We are first of all, to determine if it's one-to-one. And if you just look at a graph of a straight line like this, x plus 5 is just a straight line, it's going to have a y-intercept at 5, 2, 3, 4, 5, and it's just going to have a 45-degree angle steepness. That is definitely one-to-one. Horizontal lines would only hit it once. All right, so definitely one-to-one. Yes, function is one-to-one. And its inverse function is really easy to find. What you do is you introduce a y, you switch places between the x and the y, and you solve for your new y. So this is f inverse. So f inverse of x is x minus 5. If f is x plus 5, f inverse is x minus 5. A little surprising, but you can see it over here. If you reflect this about the line y equals x, you'll see what's going on here. Let me do it in red. So 1, 2, 3, 4, 5. So at 0, we're at minus 5, and it has the same steepness. Okay, now that point actually, I didn't draw it the best, but that point actually is over there, and this point is right there. So they get reflected across the mirror, and so we've computed our f inverse. It was definitely one-to-one, and so f inverse is x minus 5. All right, let's do. Let's skip that line and go on to 11. 11 is pretty hard. I mean, not too bad, but anyway. So determine whether the function is one-to-one and find the formula for its inverse. So, if you look at a graph of this thing, it is one-to-one, and so I would say yes, just based off of the graph. I won't graph it right now. Let's work on finding the inverse. Okay, so remember this. The technique is you introduce a y for the x, the f of x. You replace f of x with the y variable. And then you switch places. All right, now that's not a normal operation. This is the inverse operation. You switch the inputs and outputs. So you switch places, and then you solve for the new y. So you get x times y plus 5 is equal to 9. We're trying to solve for y right now, so y plus 5 is 9 divided by x. And so y is 9 divided by x minus 5. There's f inverse. It is not what you'd expect. I mean, it is the reflection of the original function about the line y equals x. All right, so there's our answer to that one. 9 divided by x minus 5. All right, we're going to do one more, and then we're going to call it good. Let's do number 12. So on number 12, f x cubed minus 3, x cubed minus 4, sorry. X cubed minus 4, definitely one-to-one. No problems there. I mean, so what I'm doing is I'm looking at the graph, and it passes the horizontal line test. So if it does, then our inverse relation will be a function. So you introduce the y, you switch places, and then you solve for the new y. So the 4 comes over, you take the cubed root of both sides, and there is f inverse. So f inverse is the cubed root of x plus 4. That's what you put right there. Okay. So it's not just the cubed root of x cubed minus 4. It's the cubed root of x plus 4. These are inverse operations. Anyway, thanks for watching.